Okay, we have a few application problems here at the bottom. The first one is kind of a review of checking to see if a function is linear. So on one like number 19, we need to look at the rate of change. Now notice the x values don't always change at the same rate, so we are going to have to use rate of change as y over x. So in this first time, I'm looking to go from 110 to 60, so that's a difference of 50. Then going from 60 to 35 is a difference of 25. The x is a difference of 2. And this is a difference of 1. Now, technically here, I'm going up in both directions, so that's plus 50, plus 25, plus 2, plus 1. So positive divided by positive will give my positive rate of change. My first rate of change is 50 over 2, which is 25. My next rate of change is 25 over 1, which is also 25. So my rate of change is the same. That's why you have to say rate of change is the x divided by y. It looks like 25 is going to be the answer, but just to make sure, I am adding 25 again there, and I'm actually adding 50 there, but I'm going up by 2, so I have 50 divided by 2 again. So it's 25 all the way across. Since this has a constant rate of change, you know it's linear, and your equation should be y equals 25x, and then you're looking for a y-intercept. In this case, they were really nice and gave you this point here. If you graph the point 0, negative 35, you go over 0 down to negative 35, that would have been your y-intercept. So just remember your y-intercept always has an x value of 0, so that'll help you find that. If it was not linear, you would just, if you did not have a constant rate of change, you would just say it wasn't linear and you would be done with that one. I'm also going to look at 21. We did one like this in class the other day. Remember, anytime you see the word per in a word problem, it lets you know that you have something to do with slope. So if I have 60 miles per hour, that lets me know that this is my slope. This is my m value. And your hours is usually your independent variable or your x. And then the other variable, distance, whatever else it is usually your y. So I have an x value there and a y value there. First thing I'm going to do is write a linear function. So to write the linear function, I'm going to use y equals mx plus b. So y equals mx plus b. And then that gives me a 265 equals 60 times 3 plus b. 265 equals 180 plus b. And then I subtract 180 from both sides to solve for b. That gives me a value of 85 for my b. So that basically lets me know that my equation is y equals 60x, because the slope comes in front of the x, plus 85 because the y-intercept goes on the end. Now it wants to know what it reads after 7 hours of driving. After 7 hours of driving, I'm going to have to put a 7 in where the x is. So I'm going to have 60 times 7 plus 85. So y equals whatever 60 times 7 is plus 85. I'll grab my calculator here. 60 times 7 is 420. Plus 85 is 505. So that would be your final answer. This is a good example of how once you have a linear equation, you can use it to solve an additional problem by substituting in a number. In this case, they gave you a time, so that was the x value. They could have just as easily given you a distance, and you would have plugged that in for y and solved for x. Please reach out to me if you have questions on any of this. I hope you're successful with today's assignment.